Welcome to What's Up with Energy, a GridX podcast. I'm your host, Georgia Knapp. Today's topic is going to be focused a lot on battery energy storage systems, but also how those relate to PV plus HEMS. And helping me learn more about this is Mauricio Olmos, Senior PV and BESS expert from Huawei. So Mauricio, thank you so much for joining me today.
Thanks, Georgia, for the invitation.
And I think pretty much everyone, even if they're not in the energy sector, knows Huawei. Or Huawei, I think in Germany is how they pronounce it?
Yeah, it would be German, yeah.
Okay.
But the real name is Huawei.
Is Huawei.
Yeah.
For anyone who might not know, could you give just a brief introduction to Huawei?
Well, Huawei is a big company based in Shenzhen, China. Mm-hmm. At least our product, our business line. Because Huawei produces laptops, phones, smartwatches. The other side, they produce components for cars, for automotive driving. Then also they have telecommunications, servers. And there's another one which I belong to, which is the energy sector. Mm-hmm. So, and then we produce inverters, we produce batteries. So everything what we could deliver for utility scale, residential scale, and also CNI scale business.
CNI?
Yeah, this is like a construction and industry.
Ah, okay.
Yeah, like in industrial systems, like for example, for let's say a supermarket or factories.
Okay.
Yeah.
And how did you get into the energy sector?
Myself?
Yeah.
Well, I studied, I did a master's on renewable energies in Germany.
Okay.
Yeah, because back at the time, Germany was the leader on these topics.
Yeah.
Yeah, because I was looking around the world actually for university focus on that, and Germany was one of the best addresses to go in.
Okay.
Yeah. So and then I focused myself on PV and solar.
And was that because like Germany was also, I think even today is one of the biggest markets for solar?
It was more because of the know-how.
Okay.
Yeah, it was not more related about the market because I didn't know after my study if I stay in Germany or not. It was more or less like, okay, these guys knows more, and I should get in the study there. And even in my study, I could choose between wind energy or solar energy. So and then I chose at the time like PV or solar.
Yeah.
Because I liked it more.
Okay. And then how did the batteries factor into that?
Yeah, back at the time when I did my master's, that's around like 12 years ago. Batteries were like incoming, but it was extremely expensive. So so it was. I did actually my master thesis about recycling of batteries. So maybe it was one of the first theses talking about that.
Yeah.
Because it was, of course, much more expensive than a PV system.
Okay.
PV system means, for example, panels and an inverter, and feed the energy to the grid, and of course, help the customer to reduce costs. And battery was, of course, too expensive.
Like twice as expensive as a PV panel?
Yeah.
Okay.
Yeah. So that was the question. Was like, wow, if I use a battery, then my ROI is extremely long, like maybe 15, 16, 17 years. So that's why battery was not really like the key of a system.
Yeah. And nowadays, it kind of feels like, if you have a PV panel, that's really great, but to really get everything you want out of it, you kind of need the battery to go along with it. Right?
Yeah. Like right now, we have totally different case. Now is the battery the star of the system actually.
Yeah.
Solar panels just an add-on. It's the producer of the energy, but the battery is the main thing because also for example the tariff of energy that you feed into the grid, it's very very low compared like 15 years ago.
Yeah.
So it makes more sense now to have our own battery to store the surplus of energy and to use it in the night when there's no sun instead of feeding everything to the grid.
And then how does a HEMS, a home energy management system, work its way into this trifecta?
Like this is now the key, I would say. Like let's see, 3 years ago there was not really like the topic.
Yeah.
But now it's the key because we've seen in the market everyone, not everyone, but almost everyone can produce an inverter or can white label the inverter. The same could also happen with several kind of batteries. But the HEMS is something that you cannot really white label. So you need an own team to develop the software, to develop all the functions that can I do. So, and with the HEMS, of course, you can save much more money.
Yeah.
So for the end customer, it's a big plus that you can have, because we are now drifting in a super fast way actually into the AI.
Yes.
And into virtuality. And if you are a company without HEMS, then you're kind of, I wouldn't say lost, but you are losing the market a lot. So you're drifting yourself, I would say, into a cheap market then.
I mean, nowadays, is there any reason for a person to have a PV plus battery without the HEMS, or do you really need all three at this point?
No, you don't need all three, but as I said, like it's the big plus. So for example, for dynamic tariff, like if you have just a PV system with a battery, you don't have this option to choose. So dynamic tariff means, for example, that the system can buy and sell energy from the grid when the energy price is very low. So this helps you the HEMS. Without that, then you are just delivering or buying the price as it is. That's it. You don't have, for example, functionalities like time of use. Some of them they have it, like a peak shaving.
Yeah.
But it's not dynamic. So that's what you need with a HEMS then.
Does having the battery make this more accessible for people in apartments?
Yes. Yeah. Well, I would say yes, because there are already competitors in the market.
Yeah.
They're using small batteries for apartments.
Yeah.
We actually also have already one system made for these kind of cases.
Okay, for apartment living.
Yeah, where you don't need anymore a PV system. But it's just the beginning. So,
Okay.
So we are just admitting, like it's for us, it's not our real target.
Yeah.
Market, but we have already something. Yeah.
And then, what advances in battery software or hardware have been made recently, especially since you've been studying them for? You said like 12 years?
I mean, this is if you go for example, let's go for the panels. So first of all, when I finished my study, we were happy to have panels with 250, 260 watt peak.
Yeah.
Now you can find some for 600, so almost the double of the power.
Of the battery, or you the PV?
No, on the panels.
Okay.
So let's go from the panels to the batteries and the inverters. Okay. So that's why the efficiency of the panels are extremely high if you compare also 12 years ago. So it's a huge jump in the technology on the panel side.
Yeah.
If you go to the inverter side, it's way more. Like inverters, they become more efficient, become bigger, better. The starting time of many inverters, they are extremely low, which means maybe 12 years ago, your panel wake up at 11 in the morning.
Yeah.
And right now it wake up already at 9:50 in the morning. So which it gives you one hour or more energy than in the back, and in the 12 years ago.
Because you mean it's waking up when the sunlight is hitting it.
So which means the inverters, because are more efficient, they need less voltage to start. Yeah.
Okay.
Yeah. So that's a huge advantage.
Yeah.
In less than 15 years, it's so much, that you cannot compare anymore an inverter from 12 years ago. It's like back on the time in the 90s, I think, when the computers came. You could buy one computer, and 2 weeks later, your computer was already too old.
Yeah.
And it's kind of the same thing with inverters,
Yeah.
because every year comes new things. Even we as Huawei, we produce also every year. Actually, we launch 1 or 2 new inverters, which are way better than the other guys.
You said every year?
Almost every year, like in this year we launched already 1 inverter, no, two inverter, 2 types of inverters. Last year also we launched also 2 types of inverters. So we're trying always to get new ones. Of course, we have some in the planning for next year.
Yeah.
So yeah, actually almost every year we bring something new.
Interesting.
Yeah, and the battery is also a huge brand. So, like, I think when I started my career, there were some lead acid batteries. So, which means the small ones that you can find also in your car.
Yeah.
And that was like the almost only batteries out there. And you had also the LFPs, but it was extremely expensive. So it was not even think about that. It was too expensive.
What would an LFP?
LFP means lithium iron phosphate.
Is it the lithium ion?
Yeah, lithium ion. Yeah.
Okay.
Lithium iron phosphate. Yeah.
Okay.
So, and the LFPs was like or extremely expensive. So
Okay.
don't touch it. At least for PV systems.
Yeah.
And right now everything is LFP. Almost everything is LFP.
Yeah.
So which means the pricing also dropped down like a lot, like more than 60%.
Oh, nice.
Yeah, if you compare to like 12, 13 years ago.
Yeah.
And of course, the efficiency of batteries, they went up a lot. So more than 90%, so which is extremely good to have 90% of efficiency.
Yeah.
The cycles went also up like hell. If you compare lead acid batteries, they have maybe 1,000 cycles until end of life.
Yeah.
And our batteries, for example, they have 12,000 cycles under end of life.
Nice.
So 12 times more than in the past. So which means we can assure that this battery is going to live around 30 years.
Okay.
If you compare with the lead acid ones, it was maybe 2.
Okay. Yeah. So that's big difference.
Big difference.
Yeah.
And pricing, it's per kilowatt hour is almost the same like lead acid batteries 12 years ago.
Okay.
Yeah.
And then, so that's how that technology has changed.
Exactly.
We've moved from largely the lead acid to
LFPs, and of course there are other new technologies coming. But
are there any you can speak about?
Well, there are some sodium, which ones I have to admit I just read about it. I had some touch with the companies that are doing this.
Yeah.
But I don't know really like how really good are they. So like I asked once one company from there doing this, and the warranty was the half of what we are doing, what we are giving.
Okay.
So the warranty is pretty low yet, and the price was higher than we sell, so we offer.
Okay.
So it's still in the beginning, but I think this is the next step. Why? Because sodium is everywhere, so it's linked in the salt.
Yeah.
So it's just in the ocean. So.
And honestly, I'm picturing a battery just full of salt at the moment.
Exactly. So and it will be easier to get sodium than, of course, lithium.
Yeah.
So if this goes through, and which I hope, then it will be, of course, way cheaper to have a battery, and way better also for an environmental impact.
Okay, because that was something else I wanted to go back to, because you said your graduate thesis was about recycling the batteries.
Yeah.
And I remember a few years ago reading something about how that is one of the issues with batteries is how can they be recycled? What's their environmental, like they help renewable energy, but then when it comes to they start to degrade?
Yeah, well, I mean, if you, for example, take one of our batteries, 30 years lifetime, it's kind of long.
Yeah.
So that's why that's why the environmental impact is not that high if you think like in a term of 30 years. Versus lead acid, for example, that you have to change every second year.
Yeah, that's true.
So in this case, you are really like prolong this lifetime, and then, I think in 30 years we will have the 100% technology to do that. However, every system that has been built, has been built and engineered by a human being. So which means it's also well known how to dismantle and how to recycle it. So it's more a question of money.
Okay.
It's like, as always, it's a question like how much money can I get, from the recycled batteries. Can I afford to pay a factory to dismantle everything, to neutralize the whole chemical stuff inside, and then to resell those parts, and it is cheaper than getting new lithium, yes or no? So I think once we can have this process cheaper, then it will be, of course, easier to recycle.
Okay. And then, in your opinion, what contributes to making a battery actually smart? Is it, the fact it's the playing with the home energy management systems, its response time? Like, what exactly is helping to make it a smart energy asset?
Well, as you said, like it's more or less like the functionalities of the HEMS. What makes this battery, of course, smart?
Yeah.
Because the battery doesn't has any.
By itself cannot be smart.
No, so it needs some commando.
Yeah.
And this commando comes, of course, from the HEMS. And of course, also from the inverter. If the customer doesn't has the HEMS, then it will come, of course, from the inverter. But it will be commando like, okay, now charge that, now charge, now discharge, and of course can be faster. It depends also of the battery. There are some batteries that are plug and play, so it's easier to install, but at the same time it's easier to deliver the energy. There are some batteries with cables, so they are of course a little bit slower than the other ones. And it depends, of course, of the technology inside of the batteries. Because of course, like if you want to have a high level batteries, then the components inside are better.
Yeah.
The heat dissipation is less so than other ones, and it depends of the pricing. How much at the end of the day the end customer wants to pay for that.
Do you think, and we're just going to at the moment talk about Europe specifically, that end consumers are aware of the advantages of having the battery plus the PV, or because I feel like it's still a lot of people, they just want the PV panel and that's where they stop.
Yeah. Well, we have different kind of end customers. Yeah, there are end customers, mostly retired engineers, for example.
Okay.
They have time, so they go really deep and make a nice research about that.
Yeah.
And I have to admit, we have a lot of these kind of customers because they like our systems.
Because it's a very niche market.
Yeah, because they check every little thing.
I mean, that tracks. Yeah.
Yeah. So I have, for example, a case of one retired engineer in the north of Germany. In Bremen, near Bremen.
Yeah.
This guy really proved everything of our system, and then he said, "Okay, I will buy it." And then he recommended by himself his neighbors. So, and then I got a call from one of our installers and say like, "Hey, you know what? I have a nice history for you. If you want to listen to it, that was history." So this guy was 100% technically. So he chose our systems because of the technical side.
Yeah.
But if you go, for example, to people, let's see, 25 plus until 45, let's say that, these people don't have time really to go so deep in the technology. So they check more about the pricing, functionalities. Maybe they read some blogs online or something like that, So, but we've seen in the market that people are asking more for batteries than in the last years.
Okay.
So, they are aware. I think the market is already aware that they need batteries.
Yeah.
Yeah.
I think especially like this summer we had, or not this summer, but this year we had quite a lot of blackouts in Europe. Like we had the big one on the Iberian Peninsula, obviously.
Yeah, actually, last week I was in Spain, exactly working for this project. from the
Okay.
blackouts. Yeah, because we've seen a lot of now people they want to have the blackout, the solution, so which is
Yeah.
called backup power.
Mm-hmm.
And yeah, backup is very common. In Germany, it's not that common. It's like waves, I
The
would say.
batteries or the blackouts?
But the backup system.
The backup system. Okay.
Yes, because I think we had some times where, for example, the Ukraine-Russian war started,
Mm-hmm.
and many people they were scared, so they were looking for this kind of solutions. Right now, it's not
Yeah.
really like a topic anymore. It's like, okay, I can have it.
Mm-hmm.
So that's why we have to combine this solution, to show the people that it's okay and it's not really that expensive anymore.
Yeah.
Mhm. But at the end of the day, I think the customer in Germany is not really so focused anymore on the backup.
Okay.
It can come maybe in 2-3 months. Maybe it will be the different. So it's like a coming and going
Yeah.
topic. In Spain, everyone wants to have it. So in Ireland, the same.
Yeah.
In Ireland, there's a lot of blackouts also. So
Are there?
yeah, in the north of Ireland.
Oh,
So
interesting.
not Northern Ireland.
Not the part that's with the UK.
No.
The
Yeah, north east. No, not
Okay.
west. Northwest of Ireland, they have a lot of blackouts.
I mean, because honestly, battery technology, it just feels so incredibly straightforward. I mean, it sounds like the main advancements that can be made are, I mean, obviously continuing to make them cheaper so that more people
Yeah.
can afford them.
Yeah.
Is there anything commercial players can do, like Huawei or even other utility companies, like can do to continue to push the benefits and make them a bit more of a mass market appeal?
Oh yeah. I mean, right now we are living in the utility battery market right now.
Yeah.
That's what you mean, yeah. Because I'm not long ago. I think it was maybe 1 month ago. Maybe in the airplane, I
Mhm.
had a newspaper and I was just reading about some topics. And one of the topic was that in Germany already we have around 12 days in average just renewable. So which means Germany is almost the half of the month is using the energy from our renewable energies, which means wind and solar.
Yeah.
So which is of course great,
Yeah. Yeah.
but that means there's not really more space for new projects. Why? Because the ROI is not that good anymore. So, so which means for investors, it's like kind of like, should I invest again in a new solar plant, and but the ROI will be less,
Yeah.
or will take longer. So now the new trend is to put on these kind of systems batteries.
Mm-hmm.
So this is the key now. Instead of losing energy sometimes because maybe there's a super production of energy.
Mm-hmm.
For example, let's say 3 in the morning, the windmills in the north of Germany.
Yeah.
There's a huge wind. They're producing a lot,
Yeah.
too much, and there's not really
Like nowhere for it to go.
exactly.
Yeah.
So this energy get lost.
Yeah.
So for these kind of projects now, people are thinking now on batteries.
Mm.
So which means utility scale batteries, and these batteries are huge. Like we're talking about 2, 3, 4 megawatt, big batteries.
Okay.
Like we also produce this kind of batteries. So
Yeah.
that's why actually this is the new trend now, and this is a trend all over Europe right now. So it's
To
not
have
only
the
Germany.
bigger
The bigger
batteries.
batteries, yes.
Okay.
If you've seen the CNI, for example, is also we have batteries of 215 kilowatt hours, which is big.
Yeah,
It's a
yeah.
lot. And only this battery you can cascade by 50. So you can see you can go in a megawatt already. So
Yeah.
it's huge. It's huge. And so the battery is a key right now.
How would so for something like you said, the construction industry, how would a battery be different than having a generator?
Yes, of course. There are some cases you need a generator. Yeah. somehow you have to turn on these batteries. So if you don't have wind, you don't have solar, you can also use a generator. Yeah, but generator is more a backup. Generator is the backup of the backup.
Okay.
Yeah.
That was just my own curiosity.
No, there are projects with the generator, but the generator is very small. It's just like the backup of the backup, and it's okay to have a backup of backup.
Yeah. Do you have any thoughts about the battery within the EV? Because this is a discussion in Germany right now, is what is it? Allowing bidirectional charging. So now you charge your EV, but then you can use your EV battery to maybe charge
your home. Home? I'm totally okay with that. No, I like the topic. I like very much the topic because we could use our car also to charge our home. So imagine you have a car, EV car, and your employee lets you charge for, let's say, 5 cents per kilowatt hour, or even for free. Mm-hmm. So you could go home, you could go to work, in these 8 hours, you charge your car, fully charged. You go home, and then you just plug your car into your home, and then you can have energy for free.
Yeah.
So it's perfect.
Yeah. The dream.
Well, it's coming. And I hope also the governments in Europe can give a green light for that, because
because it's still not allowed, right? It's just
it's like a green gray, like let's say that, and but it's it's very good. It's very cool. If I would be in the government, I would push for that, of course.
Yeah. When we talk about batteries for EVs, the battery that's connected to your solar panel and your inverter and HEMS, can't talk right now. Are those two different types of batteries typically, or is it basically the same technology?
Between cars, I mean, it depends of the manufacturer. It depends who delivers you the batteries. Mm-hmm. There are different things that can make it different, but the idea is the same.
Okay.
Yeah, it charges with different cycles. Yeah.
Okay.
Yeah.
And then looking ahead, how do you see business models around PV plus a battery energy storage system and HEMS evolving for utilities, OEMs, or even the startup world?
Yeah. Well, I think there's a big chance on the next step. So I call it next step because for now we have the dynamic tariff solution, for example. This is something that every one of us is doing now because the new trend, and it should also come, and it's also very important. But I think the next step is the virtual power plant. So is this kind of interchange of energy between homeowners, and not So that's why it's called virtual power plants, because it's not really I don't send you my energy. But I feed into the grid, and this grid gives me the energy to the other guy. Mm-hmm. But we are putting this energy in a virtuality. I don't know if I could make it clear, but the only with the help of HEMS it can work.
And then it also only works with homes or buildings that are kind of in the same area.
Exactly. For example, if I would say how could work a system VPP for Huawei, of course it would be we need Huawei systems, because our Huawei systems, they have to talk to each other.
Yeah.
So, for example, I need energy, I have surplus energy, okay, I give you energy, and I buy that energy then from you. Mm-hmm. So if we can do it, you and me, imagine you can do it with 3 million people. So 3 million customers. So that is a huge project.
Yeah.
But it also can help, of course, even the countries to reduce the production of energy made by coal or hydro plants, etc.
And then those are the trading the energy back and forth. That's all decisions that can then be made by the HEMS.
Yeah. It will be made in milliseconds. So there's algorithms that just checks, okay, who needs, who has, how can I interchange this energy?
Yeah.
Yeah. And it's, again, not sending you my energy, it's just putting my energy into the grid and then taking out of the grid to you, but and then having this kind of interchange of yeah of of money.
Okay.
No, of tariff.
Of tariff. Okay, yeah.
Yeah.
Nice. Well, I think that brings us into our rapid fire question round. So what is the most energy efficient thing you've done this month?
Oh. Not driving my car.
Yeah, no.
Yeah.
That totally works. Because this one actually, because I feel like I might know your answer, but I'm not positive now. If you could be any home energy asset, what would you be?
And the hems.
Okay, the hems.
Yeah.
I was thinking just because we've been talking about batteries so much, but
because the hems has many updates, so the hems lives from new functions. So the hems is like a guy that it grows and grows and grows.
Yeah. If a PV plus a battery plus a hems had a theme song, what would it be?
I don't know. Let me think about something like, I don't know, best friends forever or something like that, but I don't know.
Like
Dream Team.
I was gonna say from Toy Story, You've Got a Friend in Me.
Nah, I don't like this song.
What?
Nah.
What?
I hate that song.
Oh my god.
Yeah, it's
I think we just got the most shocking soundbite of the podcast.
No, I hate that song really.
No.
It's like when I hear to this, I have to shut up. Yeah. No, it's too.
But
girly.
I'm from that time
it's
period
too girly.
of like.
It's too girly. I know. Oh, the Friends theme song. That's okay. Okay, that's okay. Yeah, the Friends theme song. That's okay.
Oh my god.
Yeah, it's better. It's better. Yeah.
All right, the Friends theme song.
Yeah,
I like that. If a battery had an animal mascot, what would it be?
Tiger.
Tiger. Okay. Why a tiger?
I like tigers.
Okay. All right.
Yeah.
Nice. All right, and this last one. This one could be difficult. I'm not sure. Which famous celebrity or politician is most like a battery?
Wow. Of course, non-German.
It can be.
No, because they are very.
Oh, it would not be German.
No,
okay.
no. We have to look for a powerful leader.
You can also use a celebrity, like a movie star. Yeah. I threw in politician in case like you're not super into movies or something.
Well, Iron Man.
Okay.
Yeah.
I mean, he literally is alive because of a battery. Yeah. Nice.
Yeah.
Well, thank you so much for joining me today. I appreciate you coming all the way down to Munich for this podcast.
Thank you.
And it's great to chat with you.
Cool. Thank you.
If you'd like to learn more about the world of renewable energy or energy management systems, be sure to check out our website, gridx.ai, where we produce regular blogs and glossaries about the subject. You can also follow us on LinkedIn or on Twitter and Instagram at GetGridX.